The noise test showed in the first video, video 34, was made switching the filter at the input of the oscilloscope on and off this filter here. And the reason is that when we measure the output noise of switching power supplies, theoretically, when we insert the filter, we are measuring just the ripple. And when we use the full bandwidth of the scope, we are measuring ripple plus transient. Remember that the input filter is normally a 20 MHz low pass filter, except of course if you are lucky enough to have a top class oscilloscope where you can modify the cutoff frequency. In this last video we will also be measuring the load regulation of my device and comparing to the other commercial devices shown in the first video. I will start measuring my own device and then the commercial devices. In the sequence I will include the summary of the measurements and also the summary of the measurements made in the first video. Notice that I have two pairs of cables, one connected to the load and the other connected to the meter. I will start with the 2 amps connector. The load is on 4.846 and then I will disconnect the load 4.986. Then I will change the current to 1 amp and test the 1 amp output. 4.906 with the load, and without the load 5.072. The next one will be this Apple charger, 1 amp. 1 amp current. 4.960 and no load 5.113. Now the white Samsung. Let me change the current to 2 amps. We have to wait a bit for the emitter to stabilize. 5.316 and without the load 5.032. Next one will be the black Samsung. 2 amps load as well. 5.150, and if I disconnect the load, 5.005. Now the USB hub. Two amps load as well. 4.877, and open output 5.135. Now the 3 amps charger. Let me change the current. .68 volts, and open output 5.127. And here is the overall summary. This block here refers to the first video, output noise, and these other two blocks down here refer to the load regulation measurements. This line shows the USB voltage specification, plus minus 5%, or from 4.75 volts to 5.25 volts. And this is the formula used to calculate the regulation percentage. No load voltage minus maximum load voltage divided by the nominal voltage, which is 5 volts, multiplied by 100. And the lesser, the better. 3% of regulation means 0.15 volts. Interesting thing is that the white Samsungs and the generic charger violate the USB limits. Not much though. Also interesting is that the voltage and the maximum load of both Samsung chargers is higher than the no load voltage. And here is my power supply cluster in its place on my workbench. It's important to point out that this device has overcurrent protection, short circuit protection, over temperature protection, and over voltage protection. And its switching frequency is 1.1 megahertz, making easier the task of keeping a decent ripple at the output. That's all I had. Thanks for watching.